Hey, my name's Coleridge Smith, and I'm here to talk about avoiding database migration hell. I work for a company based in London, and we're called PodPoint, and we make these things. They're electric vehicle charging stations, and we have various applications that control them, a couple of Laravel web apps, and a Laravel-based API, and we've also got some React and React Native applications that we use that our customers use to control their charge points. My personal interests are sort of REST APIs and JavaScript single-page applications. So without further ado, let's talk about database migrations. So to start with, would you put your hand up if you're already using database migrations? Oh, cool. So quite a few people then. That's good. Oh, cool. So what is a database migration? The definition is an incremental change to the database schema, and it should be reversible. And just one point to make is that Laravel makes a distinction between migrations and seeds. Some people who are familiar with other frameworks, they might only have migrations available to them. So I thought I'd make that point. So why would we want to use database migrations? Seems like quite a few of you are using them, so hopefully you understand the benefits. But one of the biggest reasons why I like them is because your schema remains part of the project. So you can imagine you're on your first day in a new job, and you got your new boss, and he's told you to check out the project and have a look at it. And so you go onto GitHub, you check out a copy of it, and you've got the database schema there ready to use. In contrast, if you didn't have database migrations, you may have to then start sending Slack messages to people and say like, oh, hey, can I have a copy of the SQL dump file so that I can get a copy of the database up and running? And you're spending your first day kind of annoying people, bothering people, and it's just not a good way to start. So one other thing is that if you've got your database schema as code, there's no need for you to log into the production environment. So you don't need to log into your main database and sort of use your SQL client to get a MySQL dump or something like that. And that means that your developers, they don't need access to production databases, and that's just a good safety net, because mistakes do happen. You could be logged into your production database and somehow accidentally delete data or make a change that you're not supposed to do. And what you want to do is protect your company and protect your developers from being able to make those mistakes. So a database migration allows for a sort of versioned database schema, because every time you run a migration, it moves forward to the next version. And you can move forwards and backwards between versions, generally. So one thing that happened once is we built some database migrations that added some foreign keys, I think, to a table. And it turned out that there was some data in our database that we weren't aware of. And when we ran these migrations in production, they failed. And so we were able to quite quickly and easily reverse the migration, fix the problem, and then run it forwards again. So if you were doing that with maybe manually with a SQL client like SQL Pro or something, you'd have to remember all the changes you've made and then try and fix them again and then try and make the changes back again. But if you're doing it with code, then it's all quite automated, and so you can go forwards and backwards between versions. Another key point is that your dev and production environments, they'll match up, because you're going to be using the same code to build a development database as you are to build a production database. I remember once when I was doing some freelance work years ago, and I built a system that you'd log in using Facebook, and we'd store the user ID in a table, and my user ID was quite a small number, and so it fitted in as a big int in MySQL, but actually they're such long numbers that it was recommended that you should store them as a varchar, because people who had logged up a few years after me, their user ID was this enormous number. And so we made this change in development, made it in staging, changed the big int to varchar, and everything worked. But unfortunately, the message didn't get down to the ops people, and they didn't make the change in production, so the app was still broken, and nobody knew why, and it just turned out that we'd forgotten to make this minor change. Had we done it with a database migration, when we redeployed the application, we'd be able to just, it would be using the same code, and it would be done automatically, and the changes would be made without too much effort, so hopefully avoiding this sort of thing happening. And finally, they're great for testing. If you've got a suite of acceptance tests or functional tests or anything like that, you can quickly spin up a database, run some tests against it, like make sure your forms work, or if you're building a REST API, hit all the endpoints on it. And you can also spin up the database maybe using a different driver to what you're actually using in production. So what I do quite commonly is run a lot of my tests using a SQLite database in memory, which is super quick because it doesn't have to write to disk. So you start your test suite, run your migrations, it will create a database, and then we can submit forms or hit API endpoints, and it makes for really accurate testing, and you get a lot of bang for your buck because you can run the application all the way through with real data. So we're going to do a quick demo on how to create a database migration. I like to use the artisan commands because with database migrations, the file naming and namespacing and auto-loading is quite fussy because they get run in order. So let's make sure this works. Right. So the command to create a migration is php artisan make, oh, sorry, here we go. I think this will work now. PHP artisan make migration, and we'll create a roles table. So we do create roles table, and we'll do. Okay, so what we're doing is we're creating a roles table. So we're going to give it a file name, give the file name of our migration, create roles table. It's good to have some sort of convention here with your colleagues because what can happen is I can call my create migrations one thing, and then someone else will call something another thing. And as your application grows, you'll end up with a big mess of things with funny file names, and you won't be able to keep track of them. And then finally, that create argument will just wireframe our migration so that it's got some useful code in there already. So we'll run that. And there you'll see it has created the migration. And you can see that it's got that funny sort of timestamp file name. And so that's why it's useful to use the artisan command rather than your IDE to create these files. OK. Right. OK, so now we'll look at the file that we've just created. So so when you've used the artisan command with that create argument, it will scaffold the file out with some useful stuff. And within this migration, we have two methods. And because a migration can run forwards and backwards, we have an up command, an up method, and that's called when the migration runs forwards. And then we have a down method, which is run when the migration is reversed, if you need to do that. And it's really important to fill in the down method with the exact opposite of what you've just done previously. So in this case, it's just schema drop, which we'll go into in a bit more detail in a second. But you always want to make your migrations reversible. OK, so in this example, we're making a roles table. So this roles table is just going to have a column called ID, and that's going to be of type string. So we're going to use the blueprint class, which is something that comes with Laravel. And that's got all sorts of methods in it for making database schemas. So in this case, we're creating that ID column. We're going to add the timestamps, which are the created at and updated at columns that you could be familiar with if you've used Laravel a lot. And also, we're going to use soft deletes. So that's the deleted at column. So Blueprint's just got these helpful convenience methods in them that will create those columns for you. And then because this table doesn't have a incrementing numeric ID, we're going to set the index of the table to using the primary key. And we're going to call it ID. Okay, and since we've only created a table using this migration, the down method is fairly simple. It's only a line of code, and it's just doing schema drop roles. And what that will do is it will drop the roles table whenever that method gets called. So it's the exact opposite of what we've done in the up method. Okay. So moving on, how many people use database seeds then? Put your hands up. Ah, cool. So quite a few people do this as well. So a database seed will insert data into your database, and that could be data for testing or data for production, basically. So why would you use a database seed? The main reason most people use them, I think, is to kind of make your application feel real. So if you're developing a new application that needs a sign-up form or something like that, back in the old days, you may have made the application, made some changes to your code, and then you want to have a go with it. So you then got to go to the sign-up page, put your email address and password in, then go to the email confirmation and go back. And then finally, you can get in and actually use your application. But then when you get into your application, it's completely empty. So your graphs won't show anything, or if you've got tables in there, they'll be completely empty. So you'll then have to go into like SQL Pro or PHP MyAdmin or whatever you're using to then copy and paste a bunch of rows in, and it's just quite hard work. So what you do is create a seed which can programmatically insert data into your database. And another thing is that because you're making a computer program that will add this data into your database, you don't need to use real production data. So hopefully not many people are doing this, but sometimes people might need to get a copy of the production database and install it on their local machine for development. And that's quite a risky thing to do, because you could lose your laptop, you could leave it at the airport or something like that, and then you've lost a copy of your customer's data, and that could be their personal information or credit card information or anything like that. And so with a package called Faker, you can fill your database up with data which looks real, but is just completely anonymized, and so it's disposable. It doesn't matter if it gets lost. You can destroy the database and start again, and just completely start over. And this is something that we do at PodPoint quite a bit. We've got a flagship product, and it's used to control our network of charge points, and it's called the MIS, which I think means Management Information System. I didn't come up with the name. I think it's a bit terrible. But our sales team, they'll need to go out and demo this product to potential customers, and we don't want people to see real customer data. So we can spin up a demo environment for them and make a set of seeds or use some existing seeds and put in data to make this thing look awesome, because it's got maps and graphs and charts and all sorts of things in it. And what you want is for them to all look really cool, and the potential customer to think that our system looks amazing. So we do that with some fake data, and it kind of looks real, but it isn't. And again, seeds, they're really good for testing. So another thing you can do is once you've spun up a new instance of your database schema, you can then seed it and fill it up with some fake data. And then if you're running acceptance or functional tests, you can say, check a table is populated properly, or a graph looks right, or something like that, using your code. And if you're doing any API, like REST API development, you can fill it up with data and make sure that your pagination works, or your JSON structure is correct, or anything like that. Anything you could think of that you need to test. If you seed the data, then it makes it a lot easier. And also, I use seeds quite a bit to insert settings into the database. So quite often you'll have things that live in your database that can't really be config. So they can't live in your Laravel configuration files, for instance, because they need to be joined to, say, a user or an access token or something like that. So it needs to be in the database. And so you've got to get around that fact that when you initially deploy your application, you need this stuff to be in the database, but you don't want to have to sign in and remember to add all of this stuff manually. So what I would tend to do is create a seed that inserts this sort of data. So for instance, I've built a REST API that uses OAuth for authentication, and I would insert my user roles and their scopes and the application types and those sorts of things that kind of need to be joined to access tokens and users, and I wouldn't necessarily want a UI to do that. I just want it to be there without having to think about. So a seed is quite a useful thing to use for that. So we'll just do a quick live demo of how to create a seed. We'll use the artisan commands again. The file names and things like that aren't too fussy with this, so you could just use your IDE, but using the artisan commands is quite a good habit to get into, so I'll promote that. So we do PHP artisan make seed, and we'll call it roles table seeder. And it just says seeder created successfully, and your seed is sort of ready to use. So we'll go back to the presentation. And this is an example of what the artisan command will make. And you'll see it's a class called roles table seeder, which is the name that we gave it on the command prompt. And it extends seeder, which is Laravel's base seed. So any seed that you make needs to extend this class. And it has a method in it called run, and any code that is in that run method will get executed when the seed is called. So you can seed data into your database sort of any way you like, really. There are a few sort of standard methods, though. The first being is just using the query builder. So we're creating a query here that inserts a bunch of rows into the roles table, and it doesn't do much else than that. We could use our models if we've got models in our application. So in this case, it's just creating a new user with those details. So it's creating a new me in my application. Or we can use these things called Laravel factories, which are new to Laravel a few versions ago, and they're pretty useful. I'll go into a bit more detail in these in a sec, but this is just creating 5 instances of organization and storing them in my database. And the other thing to note is that a seed, it can call other seeds, so you can use this to sort of group your seeds into different categories. And I think when Laravel ships the database seeder, you would often use that to call other seeds that you've created. But what I would tend to do is sort of create different categories and things, which I'll go into in a bit more detail in a sec. So just to sort of expand a bit on what a factory is. It's a sort of piece of procedural code that describes a model in your application, and they're super useful because you can use them to just create fake instances of your models. So in this case, this is making a instance of my organization model, and what it does is it returns an associative array of information about a model. It gets passed in an instance of that package faker that I was speaking about earlier, and it's simply creating a fake company with a fake address in Great Britain. And so every time you call that, it will hopefully create a completely unique record that you can store in your database. Okay, so as mentioned, seeds can call other seeds. So you can categorize things. So I would tend to use 3 categories maybe. So I'd have my initial database settings seeder that's going to put in my sort of initial settings and things into the database. And then I'd have my test seeder, which is going to put in a sort of bare minimum of data into the database so that you can run your functional acceptance tests against it. And then I'd have sort of seeds for development and demo and that sort of thing. So you can test your application out for real almost with fake data. So the database settings category, these should just be the sort of bare minimum settings that you tend to need for your application to work. So maybe some roles or some sort of user types or anything like that that you wouldn't necessarily want a UI to edit. And And these should be added to the database at every deployment. There's a few strategies for doing that I'll go into in a bit more detail in a minute. So in the test seeds, these should be a very small subset, because actually if you have a huge amount of data in your seeds, they do sometimes run quite slowly. So what you want to do is kind of seed the bare minimum amount of data you need, and then you can also top stuff up using factories, because you could call a factory within a test to add more data if you needed. And you would just call these test seeds from within your test environment. So within Laravel, you could stick a call in your test case to seed your database, because you can call artisan commands from there. And your seeds for development and demos, this should be as much data as you can possibly fit in, like hundreds of users or hundreds of products or anything like that, because you want your application to feel as real as possible, so that when somebody's sort of using it and running through it, it feels real, but they're not looking at real data from real customers on their development machine, or when your sales team is doing a demo or something like that. And you just tend to call this on an ad hoc basis, just whenever you, like say you're developing and you messed up something and you just needed a new database, you'd remigrate it and then you'd seed it again. Or if you were spinning up a demo environment for someone giving a customer demo, you just use your demo seeds then as well. So as mentioned, we have a couple of strategies that we'd use when we're putting data into the database in production. This applies to your kind of demo seeds as well, actually, and your dev seeds, but mostly in production. And this is sort of truncate and append. So the truncate strategy, you have a table of data in your database, and you want to reseed the table, and you want that table to be full of new data, really. So what you could do is truncate that table just using a SQL truncate command, and that will completely clear the table out of data, and then it's fresh to have the new data seeded into it. Or you could use something that I call the append strategy, and this is good for sort of database settings and things like that. And what it would do is check to see what data is in the database table already, and if there's stuff in there that shouldn't be in there, then it'll delete it, and if there's stuff in there that's missing, then it will add the missing data. So it's a bit more delicate than, say, truncating the table and then just reseeding it. And this makes it quite good for production, because if you're putting database settings in, you probably don't want to truncate the table, because you might be using a zero downtime deployment, and there'll be like a split second where the table will be missing data. And if at that point someone tries to log into your application or make a request to your API or anything like that, then your application will probably error out. And so that's why the append strategy is probably better for that. So yeah, as mentioned, I'd probably recommend to truncate the table before seeding it with test and development data. And then if you're putting production settings in, I would try and append it rather than using the truncate method, especially if you're using a zero downtime deployment or something like that. Okay. So I've seen on Stack Overflow a couple of acceptance answers which suggest that you should use a migration to insert settings and things into the database. And that may seem like a good idea. You think like, oh, I've only got these 5 roles that I need in the database, and that's all the roles that I'll ever need. But what will happen is your application will probably grow and it will evolve, and 5 roles will become 6, and so on and so on and so on. And because a migration can only run once, you can't just sort of edit the migration and go, oh, I need these 6 roles now, or I need these 10 roles now. So there's no going back once a migration is run. So I think a seed is a much better thing to use, because you can edit the seed and then run the seeder again. And if you're using append strategy, then you can just, it will work well in production. It will delete stuff that you no longer need. It will change stuff, and it'll work a lot better than having lots and lots of migrations. And we learned this the hard way at PodPoint. If you can see, this is a sort of GitHub a screen grab of our database migrations folder in one of our old Laravel applications. And it's pretty long. It just goes on and on and on. And it just carries on. There's hundreds of migrations in there, and it's just impossible. And they're all stuff like, oh, this role has changed now, so we're going to need to change this information, and they just get complicated. And so if you're seeding it, then it's much better. And you just don't make that mistake, because it took us weeks to fix. We basically had to really pull out the seeds, the data that was being seeded into the database, and split it apart from the migrations. And so we wrote a new set of migrations that could create the schema from scratch, and then we wrote a really good set of seeds that inserted all the settings and things like that. And then we had a really cool set of test seeds that worked really well with our test suite, and then some really cool seeds for our sales team to demo to customers. So anyway, we'll move on to the different strategies that you could use with database seeding. So we'll start with the truncate method, and what you need to do is truncate the table before you seed it. But what you probably have are some foreign keys and things like that. So it's not quite as easy as just calling that db table truncate. You'll often have to stick one of these in, which will disable foreign key checks, and then you'll want to re-enable them again after you've run your seeds. And that kind of breaks a rule a bit, because, or a rule that I've made for myself, because we're putting SQL into our database seeds, and that causes some problems, because what we want is something that will run on all database drivers generally. We want this stuff to be able to run on MySQL, and we want it to run on SQLite in memory so that we can do super speedy tests. So that's another negative factor for the truncation strategy, which may or may not cause people problems. But yeah, this is an example of my truncation strategy seeder. So we have an array of tables, and these are the tables which are affected by this seeder. So in this case, we're going to be putting data into the organizations table, the organization user table, seeder, table, etc. And then we have an array of seeds that need to be run to repopulate those truncated tables with data again. And then we have our command, which will truncate the table. So it disables the foreign key checks. It loops through all the tables which are affected, and then it truncates them. And then we have a nice message just to say that the table was truncated. And then once we've done that, we can re-enable the foreign key checks again. And then finally, we have our run method, which is the method that's actually with the code in it that gets executed when this seed gets called. And what it does is it calls our truncation method of this class, and it runs through each of the seeds and calls them individually. So that's how I'd achieve sort of truncation strategy seed, category seed. And so this is an example of one of the seeds that was called by that previous seeder. So it's got a run method, and since it's running on an empty table, we don't need to do anything other than just repopulate it with data. So in this case, we're using a factory, and we're going to create 5 instances of the organization model and call create, which writes them to the database. So in contrast, if we have an append strategy seeder, we don't need to worry about any truncation or anything like that, because it's going to manage that itself. It's going to look for data that's already in the database and sort of delete it or add to it if it needs to. So in this case, we just have an array which contains the names of all the seeders that need to be called by it. And then in our run method, what we need to do is loop through all of those seeds and call them individually. You could, of course, just have multiple calls to call, but I prefer to code it like this because you're not repeating yourself. Okay, and so this is an example of one of the seeders that was called by the previous class. So in this instance, we're going to fill up our grants table with the possible OAuth grants that my application needs. So in this case, we just have password, refresh token, and client credentials. And then you can see the run method is slightly more complicated. So what we're going to do is we're going to use the query builder to select and delete the grants which are not in the array that was specified by this class. And so that deletes out the grants that we no longer need, if there are any. And then we're going to select the grants that are remaining in the database and sort of pluck their ID. And then what we'll do is create a diff of the two arrays. So we're creating a diff of the grants that should be in the database and the grants that are already in the database. And so what you'll then have as the result of that is an array of grants which need to be inserted. And then we'll loop through and insert those missing grants into the actual database. Okay. And just one more point is that you need to code defensively a bit here because when you're calling a seeder in production, you'll have to use the force command because Laravel doesn't quite want you to do this unless you're doing it manually. And so I tend to put a call to a method a bit like this that sort of checks, is the application running in a production environment? And if it is, we just output a message and say, can't do this, and then just kill the application using PHP's die command. And that prevents you from, say, calling a development seeder in production and deleting all of your users and replacing them with fake ones from Faker, which would be a pretty bad outcome, I think. So now we're just going to put all this together and show how it all works. So this is a window of SQL Pro, and it is an empty database. So there are no tables in it, there's no data in it, it's completely empty. And so what we're going to do is call one of our migrations. So we'll do PHP artisan migrate. So this is the command that you'd run. Oh, can't tab. Let's start again. PHP artisan migrate, and we'll call that. And it will run through all the migrations which haven't been run yet. And also, if you don't have one, it will create the migrations table. And so now, if I refresh this, we've now got a bunch of tables in our database that we need for the application to run. And we have a table with all the migrations which have run previously. So this is how Laravel knows what's happened and what it needs to, which migrations it needs to run and which migrations it doesn't need to run. So the next thing we need are some settings in there for our application to work. So I'll just clear this and do PHP artisan db seed. And this command will call the default Laravel seeder, which is just called database seeder. So by default, it will call that. And this is the one that I'm going to use to insert my database settings. So we'll call that. And it'll tell us all the seeders that it's run. And so now we can look at the roles table, and it's added in a bunch of roles that we need, and then it's got some grant types, and I think there's, oh no, the clients get added by the next seeder actually. And so the next thing we need to do is add in some fake data so that we can do a bit of development work now. So we'll call PHP artisan db seed, and then we'll give it a class argument, So I've called my development seeder very imaginatively. And so this is using the truncation strategy. So it's going to go through all those tables that I specified in that array earlier and truncate them, and then it's going to run the seeds on them. And you notice it's running quite slowly because it's adding in a bunch of fake data. Unfortunately, this is one problem that I've noticed with Faker sometimes, is that it doesn't quite have enough parity. So I think it's probably, yeah, it's used the same email address twice, and I've got a unique thing on it. So we'll just try running that again. Otherwise, we'll give up on it. So yeah, as I was saying, it can run quite slowly because it's adding quite a lot of data into the database. So this is why I would tend to separate my development seeds from my test seeds so that your tests can run super quick if you need them to. So that seems to have worked this time around. So now if we look in the tables, so we've got a whole bunch of patients in there because this is like a reporting application for a medical company. And we've got some reports and some revisions for the reports, and this is all sort of useful data to the application, but it's all completely fake, so we're not running any risk of losing any real customer data. Okay, let's get the slides back on. Okay, and one more thing, one more mistake that we made. We made some of our seeds and our migrations very, very complicated. This is just, I don't even know what this is doing, actually. It's got so much stuff in it now, and it was just, it's really bad code, and it's selecting, it's joining, it's just no, just keep it really simple if you can. I mean, I know some applications have got really complicated database structures, and it may be impossible to avoid it, but just a few lines, just make it insert some data or delete some data, and try and keep it at that, because it is hard work. And so my final topic is, what happens when you have two applications? In this case, they're two Laravel applications, and they need to speak to the same database. What do you do? Because you've done a load of work, and you've sort of built some really nice migrations, really nice seeds, but now you need a REST API because you've decided that your web app, it's good, but you need it to support iPhone and Android users. So what do you do? Because you need to be able to test your API, but you also need to be able to deploy your web app and have it make changes to your production database. So this is where Composer comes in quite handy. So what we can do is we can take that database directory from Laravel and actually package it up into a Composer package, which can be privately distributed between your two applications. And so your web application, that will maintain control of your database, and your API can now just have a dev dependency of your database package. So your web application, its role's not going to change. Every time you make a deployment to it, which has got some new migrations to run or an updated seeder or anything like that, it will make those changes to the database, and your API, it's going to have it as a Composer dev dependency. And as said, we can make this private, so at PodPoint we use GitHub as our source control. So we have our database package as a private repository on there, and it loads it in using Composer, using its Git feature, instead of having to publish any of this to packages. So this is a sort of example of what our database package looks like at PodPoint. So it's pretty similar to your original database directory in Laravel that many of you are probably familiar with, since you all seem to be using this sort of thing already. So we have a composer.json file, which is the sort of required package from Composer, the required file from Composer, which describes the package. Then we have a directory called migrations, and that contains all of our migrations in it, which is exactly the same as what you're familiar with in Laravel. We've got a README file, because I'm a friendly developer, and I don't want people to annoy me all the time, actually, asking me how this stuff works. And then we have a source directory, and that contains our seeds. And I'm using PSR4 here to auto-load these seeds, because actually it's really cool to be able to namespace seeds and have them in different directories and things, because in this example we've only got a few seeds on display, but we could actually have in production and in development a user table seeder for whatever reason. And so you want to be able to distinguish those two seeds without having to have like production users table seeder and development user table seeder and demo user table seeder. So PSR4 is quite a useful strategy for that. And this is what the composer.json file would look like in your database package. So we've given it a name, so it's PodPoint database, and it is a type library. There are many more things in there. You probably need some dependencies and dev dependencies and stuff. But actually what we're interested in at the moment is the auto-loading. So we're using class map for the migrations table, the migrations directory, and that's lifted from the Laravel configuration. And as mentioned, we're using PSR4 to auto-load the source directory so that all of our seeds can be namespaced into their folders. And so now we're going to install this database package into our main web app. And this is going to have it as a main dependency so that it's available in all environments, so that we can have it in dev, we can have it in staging, in CI, and in production, so that everywhere the app runs, it's got a copy of the database. So we've put it in the required namespace, so it's PodPoint database version 1.1, and we use semantic versioning of this so that we make sure that the two applications are running the same version. And then the final bit of configuration for the web application is we need to tell Laravel where this database directory actually is, because it's expecting it to be in the database directory in the main root of the application. But actually, where it is now, it's in the vendor folder. So within the app service provider, we can do this.app.use database path, and we can give it the path in our composer directory. So that means that when you do PHP artisan migrate, you don't then have to give it the argument of path to tell it where the actual migrations are. It will just run automatically, and everything will work as normal. And so within the API, so this is the composer.json file for our API project, you'll have it as a dev dependency, and it will then only load the database package within development environments, and that will mean that you can spin up a database on your local machine or in CI or something like that. And so, because the API package it isn't in charge of the database in production, so it doesn't need the seeds or anything like that, and you don't want both applications trying to seed the database at the same time. And again, in the API package, you can make the same call in your app service provider, or you could even create a new service provider that tells Laravel where this database directory is, so it's exactly the same as in the web app. So now what we've achieved is a web app that's in charge of the database and kind of changes the schema, seeds it, does everything that you need it to do in production. And then we have a second Laravel project, which contains our API, and that can spin up a database so that we can run run tests and things like that against it. Okay. So just to summarize, you should only use migrations to manage your database schema. Just avoid using them to insert any data. And avoid using raw SQL in your migrations as well, because it means that they're no longer driver agnostic. And try to keep things as simple as possible. And for database seeds, remember that seeds can call other seeds, so it is possible for you to categorize them and have seeds that call other seeds and do special jobs and things like that. And it is possible to use a seed in production as well. So instead of using a migration to insert those settings into the database, perhaps think about using a seed and keep the seeds as simple as possible as well, because it's hard work when they get out of hand. And finally, it's quite a lot of work to build a database schema like this. It's one of those things that you might not want to do, but actually if you've got a well-maintained set of seeds and migrations, then it will save you a lot of time in the long run. And you can then package them up and share them between projects if you need to using Composer. So thank you very much for listening.